Well, as we're working with angles and angle measures, we also have to consider and study how angle measures can also be described as radians. And the idea of a radian for an angle measure comes from this here as a unit circle. Now, the circumference around a circle is 2 pi, and we can see this here on this diagram where we have both angles. If we're looking at angles in standard position with an initial side and a terminal side, that we would have angle measures described both in degrees and radians. And so here along the positive side of the x-axis, we see 0 degrees and 2 pi. And so 2 pi is the measure going from the positive axis all the way around once, one full circumference around the circle. It would be 2 pi radians, just as we might also recognize that as going from 0 to 360 degrees. Now with that, here at the 90 degree, what we would consider the 90 degree axis, well, we see that is pi over 2. And at where we would think of as 180 degrees, well, that's also defined as pi, and so on and so forth. And these measures here, 30, 45, and 60 degrees, or pi over 6 for 30, pi over 4 for 45, and pi over 3 for 60, are what we call general angles. Now, if we've got angle measures that can be either in degrees or radians, then we've got to have a conversion ratio if we're needing to convert from degrees to radians or from radians to degrees. And the conversion ratio from degrees to radians is pi radians over 180. In other words, 180 degrees equals pi. And as with any conversion ratio, we've got what we're converting from, and then in the denominator of our conversion ratio, well, that is, the denominator is what we're converting from, and the numerator is what we're converting to. So again, a conversion ratio is always based upon where the numerator is what we're converting to, unit of measurement we're converting to, over what we're converting from. And pi radians and 180 degrees are equal to each other. And this is what we also call dimensional analysis. Now, from radians to degrees, we see the opposite. We're converting from radians to degrees. And so our numerator then for our conversion ratio is described as 180 degrees over pi radians. And again, 180 degrees and pi are an equivalent to each other. And we can see this going all the way across the unit circle. At 120 degrees, that's 2 pi over 3. 135 degrees is 3 pi over 4. 150 degrees is 5 pi over 6. We get to 210 degrees, well, that's 7 pi over 6. 225 is 5 pi over 4. 240 is 4 pi over 3. And just continuing on around, 270 degrees is 3 pi over 2. 300 degrees is 5 pi over 3 in radians. 315 degrees in radians is 7 pi over 4. And then lastly, with these general angles, 330 degrees, its equivalent is 11 pi over 6. And so we're going to do a couple of conversions. And this here follows along with example 4 on page 801. So let's jump over here and let's do a couple of conversions from degrees to radians and from radians to degrees. So here we are. We got instructions to convert between degrees and radians and vice versa. And so let's see, we got 120 degrees, so we want to convert that to radians. And so let's see, so we would have 120 for 120 degrees times pi radians over 180. Let's see, and we could do a little, that's the same as 120 over 1, if that helps in this. And let's see what we've got here. We could do a little bit of reducing. Both 120 and 180 are divisible by 60. I see, because 12 and 18 is divisible by 6. So let's see, 60 into 120. That goes in there 2 times, and 60 into 180 is 3 times. And so when we multiply this conversion ratio out, converting 120 degrees into radians would equal 2 pi over 3 radians. All right, let's see. Now we got one here where we got 3 pi, negative 3 pi over 8 radians, and we're going to convert that to degrees. Well, let's see. We got negative 3 pi over 8, and then our conversion ratio would be 180 degrees, what we're converting to, over what we're converting from. Well, the pi's are going to cancel, okay? So then I got negative 3, and let's see, will 8 go into 180? Yes, it'll go in there. 8 will go into 18 2 times. And we got 2 left over. Not exactly, will it? Okay. Well, let's just go ahead and multiply that out then. I guess, well, let's go ahead and do a little bit of cancellation. And if we go in there 2, that'd be 4 over 90. And then 2 again would be, well, let's see if we can reduce this by 4. So 4 going to 8 2 times. And 4 going to 18. Let's see, 16 would be 2. Leave us 220. So that'd be 25. Yeah, 25. And so does that sound right? 110, 75 over 2. Something doesn't sound right on that. Oh, go 4 times. 4 going to 18 4 times. That's what's wrong. 4 going to 16 4 times with 2 left over, 45. All right, so then we'd have negative 3 times 45, and that's going to equal negative, well, let me get my calculator out. I think that's 135 it is. Negative 135 over 2. And let's divide 2 into negative 135. So it's going to be negative. We got a negative divided by a positive, so our quotient is going to be a negative. And say 2 going to 13 6 times. Got 1 left over, so 2 going to 15 7 times with 1 left over. And that'll be 1/2, so negative 67.5 degrees. That's our conversion from negative 3 pi over 8 radians into degrees, which would equal negative 67.5. So remember, we got a conversion ratio. Our ratio is some form of pi over 180 or 180 over pi, depending upon whether we're converting from degrees to radians or radians to degrees. And our conversion ratio is always based on the numerator will be what we are converting from, and the denominator is to what we are converting to. Have fun with this, because it is a lot of fun. Get some practice in.